Take care. All right, so that is nobody. I thought somebody would at least do it while we were waiting. But Monday is the last time to sign up for presentation date, which right now is actually the first time you can sign up for a presentation time. So I'll give you a minute or two to talk with your group if you want to talk about a presentation time. But the Calendly link is active. Please only sign up for one time. If you and your teammate sign up for different times, like I have to cancel one of those, and I'm going to cancel whatever one I think will make you the most mad because I don't want to have to do that. But yeah, sign up for a presentation time. They're the last 3 lectures of the semester and also the final exam time. So if you're looking to get out of town earlier, if you're trying to book a flight or a train or something or a bus earlier in the week, make sure you sign up for a presentation time. Don't wait for people to take all the other times and then say, Professor, I have to leave town. I have to miss the presentation. Nope. Make sure you do that now. Get your presentation time earlier if you're in one of those situations. And yeah, I'll give you a few minutes to look at that because I know y'all want to talk about it. What's up? It's the last 3 lectures, but we have this Monday lecture hanging out on the 11th, so it gets a little weird with that. Oh, my deadline's in the wrong spot. This deadline should be down here. And nobody called me out on this, I guess because we're not even close to it, but I put 3:30 a.m. to 6:30 p.m. It's not quite when the final exam is, so if we refresh this. Of course, the Wi-Fi is going to mess up my timing here. Oh my goodness, this Wi-Fi. All right, 3:30 p.m. Yay. I guess you can email me. Or actually, yeah, probably email. After the deadline, am I on the mic? I'll say this for everybody. After the presentation deadline, anybody who didn't sign up for a presentation, I'm just picking a random time for you, just so you know. And then to more answer your question, after the presentation deadline, no, you're not even listening. Never mind. To more answer your question, after the presentation deadline, I'll put the schedule on these days. I'll put it on the course schedule. But you can email me before then just to make sure you're going to get your slot so you don't get the random slot. And then even if you do get a random slot and I see your email after the fact, you can complain to me and yell at me. I'll do some trading. I'll fix the mess I made. But Calendly will send you a confirmation as well. It was someone took the last slot too. Yeah, send me an email or talk to me after class. I'll just pull it up. I don't want to pull it up right now, or I don't want to dox anyone. Okay, everyone good with that? Just to make sure everyone heard, man, we got a lot of empty seats in this class at this point in the semester. Just to make sure everyone heard, though, except the people who aren't here. If you don't, that's why I don't announce this, by the way. I do it during lecture, so anybody who isn't here, they don't get their first pick of presentation times. But if you don't pick a presentation time, it's not the biggest deal. You'll still get a presentation time. You just won't get your pick of it. So after the deadline, any teams that didn't sign up for any times, I'm just going to go through the slots that are left and start assigning things. So you won't necessarily get to choose, I guess. That's all I want to say there. Any questions before we get into it today? All right. I had to go through 2 116 lectures, but we finally got here. I'm excited for this lecture. This week and the week after break, these next 2 weeks of content, it's mostly new content, so it's more work for me, but I'm excited because they're topics that I've been wanting to add to this course for a while. So OAuth 2.0, finally. Maybe next semester I'll have it so it's part of a homework or the project, but y'all just get it as kind of content, but we can use OAuth 2.0 to do the email verification as part 2 of project 4. So you may or may not run into this depending on which APIs you use. So OAuth 2.0. In your careers, you will run into this. This is very, pretty ubiquitous out there. If you want to use a third-party API, you're going to be using OAuth 2.0 pretty much for sure these days. So you will see it. You might not. Let me just say, you'll see it. You'll see it in your careers. All right, so let's talk about what this is, what OAuth 2.0 is. But before that, we have a little more background, or at least a little refresher to do. We talked about web APIs and RESTful APIs specifically way back in the semester. So let's do a quick refresher on what that was all about. So what sites have, and I didn't really talk about it in this context either. So sites will have APIs. It's very common for an app to have an API to be able to interact with your data programmatically. And the typical setup is you'll have some app that you're going to consume as an end user. And the typical way that they're going to be set up is there's going to be an app where you just use the app. That should be straightforward. That's the front end of their website where you interact with their user interface, whether it's a web app, whether it's a mobile app, whether it's a desktop app. You're going to use their interface to interact with their server. And, well, that's what we've been building all semester. Yes, of course. But then they'll also have an API in addition to their front end, so you can interact with their service programmatically. You can write scripts and programs and other apps that are going to interact with that API directly by sending HTTP requests directly to the server without using their front end. That's the functionality that we want from an API, or at least a web API in this context. That's the functionality that we want. We want to write programs that are going to connect to our apps and control our apps. And that lets us interact with the data. We can connect to our private data even using these APIs. And one example, of course, is to start and stop music. I use the Spotify API to do that. I have a program that runs and then tells Spotify to start and stop my music at a given time, which does use the internet. Even though everything's kind of local on my app, I have to connect to Spotify's API server, tell it to play my music, and then the server tells my machine, my Spotify desktop app, hey, start playing music. So it does use a web API to do that, even though it kind of doesn't have to, but that's the way it works. So APIs use endpoints. This is a term I probably used in lecture. I probably slipped and used it a few times in lectures, but I never really defined it, so let's define it. An endpoint is a combination of a path and HTTP method. So we've been writing endpoints all semester. That's what we do with, what we do with web apps. We write endpoints, and then we write front ends that consume those endpoints. With an API, you're opening up those endpoints directly to the users. That's what we want with an API. So some examples, if I post to the path chat message, I'm adding a message to chat. If I send a delete message, delete method HTTP request to chat message / some message ID, that's going to be to delete a message. These are two endpoints that you programmed that you had to code in your homework assignment in your homework server. These are endpoints. Those are exposed as an API. as long as somebody, in this case, it's a little weird because somebody would have to grab their auth token and attach it to those requests. But if they did that, they can access these endpoints without using your front end. They could write some script or some third-party app and connect to this if they attach their auth token, which is bad, which is one of the things that we want to talk about today with OAuth. But those are two endpoints. We call those Web API endpoints. For Spotify, to play music, I'm going to connect to the Spotify API version 1, access my player, kind of the path kind of explains what it is, and then play my music. If I hit this endpoint with a put request, that's going to start playing music. For GitHub, if I want to create a GitHub issue, I'm going to connect to their API with my repo/issues, and then this is a post request. The body of the request is going to be all the content of the issue. I didn't look at it specifically. I haven't used this one personally, but probably as a JSON object for the issue. I'll just go to GitHub in most cases, or some other app that somebody wrote. And if you want to get all the issues for a user, this would be the same exact path, but a GET request. So it is common. One of the things I want to point out with this one, it is common to have the same exact path, but with different HTTP methods. It's why this was set up this way in the homework. Same exact path, but different methods for different pieces of functionality of the same data. Whether I want to create an issue, whether I want to get an issue, whether I want to delete a chat message, it's going to be different things. And when we did the RESTful API stuff, we also did put to update. We had the CRUD operations. I want to create, retrieve, update, or delete my data. Then we had the HTTP verbs, post, put, delete, and no, I'll get there. Get. It's on the slide. I thought I was missing one of them on the slide. I should have just looked at it. And get for our methods. And this will get, like this one will get every issue, but if I do slash and then the issue number, I can get a specific issue as well. For our L, for our CRUD L, or CRUDL, this is the list operation, and then with the specific issue would be our retrieve. So that's our web API. We're going to have web API endpoints. Most of them are REST APIs, or at least mostly RESTful APIs. And that's how we're connecting with data programmatically. If we want to write software that's going to connect to an API, connect to our apps, we're going to look up their API documentation and write code that consumes that API by consuming their endpoints. So that's a web API. How do we connect to this? Well, connecting to it, pretty easy. Using an API, pretty straightforward. It's easy. Like if I just said, write an API and have people able to connect with it, you're all going to be able to do that. In fact, you've already done it. You wrote that delete endpoint. We figured that out. It's fine. How do we do it securely? That's what makes this a whole conversation. How do we do this securely? How do we, in a safe way, connect to this API? So for a single user, it's actually not that hard, not too bad. For a single user, what we could do, what we actually did do with the delete endpoint, because we didn't call it an API, they consumed it through our front end. It was a little different. But what we could do, even if we expose that as an API and advertise it as an API endpoint, we could have them send their auth token. We already know how to do that. They send their auth token. That's how we did verify their delete requests. They send their auth token as a cookie. If it has that auth token, we look up the user, make sure it is the user that they say they are, make sure they're allowed to take the action that they're trying to take, and then let them take that action. That works. And that's, if I just gave this as an assignment, write a secure API, that's the solution I would expect most or all of you to come up with is, hey, we already have these auth tokens. Why would I build anything else? Which I think is reasonable. It does have downsides, though. One, it gives full access to the entire account. Once somebody has that auth token, they have full access, and the first thing an attacker is going to do if they get an auth token is change your password. Now they own your account, and you can't even get in. And hopefully the app has some email verification set up, so you can't change the password without verifying the email and all that. Or some two-factor authentication, something. But that's going to give full access with no restrictions. Which can be bad. Can be pretty bad. And they're not designed for that. Auth tokens are designed for authentication, right? They're not designed for API access or what we call authorization, which is a little bit nuanced difference. But what we can do is issue an API key. A user is going to authenticate with either their username and password or their authentication token. They're going to authenticate with the server and politely ask for an API key. They're going to say, can you generate an API key? The API will say, sure. The server will say, sure. Let me generate an API key for you. It's going to be some long cryptographically secure key with tons of entropy. Give you that value, and then whenever you want to consume the API, you send the key, they verify the key in the similar way that we would verify an authentication token, and then you're allowed to access the information in the API. There's a few advantages to this. One, the key is only used for authorization, meaning are you authorized to take this action? They're not authenticating you, so they're not authenticating that you are the owner of that data. They're just authorizing that you are allowed to access that data. So you could generate this API key and give it to someone else and say, hey, you can access my stuff. With that API key, you don't have full access to the account. Nobody's going to change your password or anything, but you need to trust them with whatever what we call scopes that API key has enabled. So with this API key, we can have restricted functionality. We can say these are the scopes, is the vocab we use, that this key is allowed to use. So if I want to let you view one of my private repos, but I don't want you to be able to access anything, I could, at least in theory, it'll be OAuth, of course, by the end of this. In theory, I could ask for an API key, a GitHub API key, that only allows you to access my private repos, but not edit anything, not make any pushes, not create issues, not do anything else. Just view the code and then give you that key and say, here, you can go check out my private repos. So we can have restricted functionality. It's not just full access to absolutely everything, but restricted functionality for that key. And these keys can be somewhat public. They're not as sensitive as authentication tokens for that reason, because they're restricted access, or can be restricted access. Oh, I have a duplicate slide. I already got a mistake in here. Okay. So, and the way this one works is users going to register and log in just like they have before. You have an account with this app, with this service. The service is going to give you an authentication token. These first two back and forth, this register, login, we've been doing this for a long time now, over a month now. And then once they have that auth token, they're going to send a request for an API key that has the auth token, because we need to be authenticated to be able to get this key. Server responds with the API key. We access an API endpoint. We send the API key, potentially the API key only. This request does not have to have our auth token attached to it at all, which is important. If I'm writing a script, it's bad enough I have to put my API key somewhere associated with that script, maybe in an environment variable or a separate file, but I need it somewhere in there where the program can read it. I don't want to take a risk of exposing an auth token in that way. An API key, if it's compromised, it's definitely a bad thing, but less bad, I guess, than compromising an auth token. So I'm going to send just my API key in my code that's accessing this endpoint. Because if I'm not writing code to access the endpoint, I'm just going to use the front end of the service. The whole point of the API is to write code that connects to the server. This is really for devs. This is for us, not for just standard users. And then the server responds with whatever I requested, which can include private data. Can't even change my data. I can change the state of data on the server in my name if I use that API key to create a GitHub issue. That issue is going to be created with my account. Like it'll say Jesse Hartloff created this issue. So that is authenticating people to create issues in my name if that API key is associated with a request for one of those API endpoints. That's like I'm doing that. Okay, so what's OAuth then? I haven't even mentioned OAuth yet, and that worked pretty well on the last slide. Like this is fine, right? So where's OAuth come into play? OAuth is going to come into play in this situation, where you have an app that you're writing, and you want users of your app. You have users of your app, and you want to connect to a third-party API on your user's behalf. This is the setup that we have that OAuth is here to solve. So my user is enjoying GitHub. They're a fan of GitHub.com, and they have repos and all kinds of crazy stuff. And I want to write some software. I want to write an app that's going to use the GitHub API on behalf of my users. So maybe I have a bug reporting app that you go to my site, and it has really nice UI and forms and stuff to be able to track and manage your bug reports. And as part of that app, whenever somebody files a bug report, it's going to create a GitHub issue in their GitHub repo in their name. Not in my app's name, but in my user's name. Like as if that user went to GitHub and filled out the GitHub issue on that repo. So maybe my app does that. Maybe I'm building a Scrum board. For those of you who have taken or are taking 442, maybe I want to build a Scrum board app that's going to create issues whenever I create stories and tasks in my Scrum board. And people can say, hey, I'm assigning this task and drag it into different flow lanes and stuff. It automatically updates the tags on the GitHub issues. Maybe that's something you want. You want to basically build Zenboard. They're not, bless you, they're not using Zenboard anymore. I got this Trello now, and I don't think Trello has that functionality. But
it was just down.
Oh, I didn't even hear it, to be honest. So maybe you want to build that app. So what we have a need for is to connect to the GitHub API on behalf of our users. That's the key part of OAuth. Or maybe we want them to be able to see their private repos. Maybe I'm building an app that just visualizes their repos in a really neat way. Maybe they can see all their Git history and all the branches and everything. And I got a really nice way I want to visualize that data. But I need access to their private repos if people want to use my app for their private repos. For the public repos, it's public, whatever. But for their private repos, I would need them to authorize me to be able to access those private repos. Or maybe you just want to sign up with GitHub button. Maybe you don't want to handle auth at all. Maybe you don't want to think about authentication and salting and hashing passwords and being paranoid that somebody might compromise the database. And you don't know if you trust your junior devs who have access to the database and understand how to crack hashes, and some of your users have weak passwords. Maybe you just don't want to bother with any of that, and you just want to sign up with GitHub button, or sign up with Google button, or sign up with Microsoft button. Maybe you want one of those buttons, which are all working with OAuth 2.0 these days. So a lot of different reasons why, the whole point of that, a lot of different reasons why we would want to use a third-party app. So we want to write an app that's going to use a third-party app on behalf of our users and access and modify their private data. If it's public data, who cares? We're just going to request it because it's public. We can do whatever we want with that. But when we want to edit their private data, or when we want to actually edit public data in their name too. But anything, we want to do something on behalf of the user, we want to write code that's going to consume that third-party app as the user. Or on behalf of the user. I have to be careful with the way I say it, because I'm going to compromise one of my slides. So how do we do this securely? This is a much harder problem, because the API key, that kind of solves a lot of things. But when we're giving that key to other apps, so from the user perspective, I'm using two different apps, and this app wants to consume this API in my name. I go to this app and get a key and just give you my key, would be the current solution. That's not quite so secure. So let's try a few things. Don't do any suggestions on this slide and the next slide, please. Never, ever, ever, ever. Hopefully I have enough bright yellow on here. I tried to do in bright red, but it didn't show up as much against my background. But never do this. Don't ever, ever, ever do this. But one possible solution to this is to ask your user for their GitHub username and password. Hopefully you all know to not do this one. But just in case, let me give the reasons why this is so bad. because this is super effective. Like, it will get the job done. Believe me, it'll get the job done. But we don't want to do this. One, we did a lot of work hashing and salting, so even our sysadmins don't have access to anyone's passwords. We're storing salted hashed passwords, so nobody can read those passwords. Not the attackers, not the devs, not the sysadmins, not IT. Nobody can read those passwords. We don't want to do all that and then just be like, hey, for that other app over there, just give me your password. It's cool, bro. Don't worry about it. We don't want to do that. That's just shady at best. But also this implies we'd be storing that password too. Like, we can use that password to get an auth token and then maybe use that auth token to masquerade as the person, and then store the auth token, which is pretty bad in itself. Like, we store hashed auth tokens also. Nobody should be able to know the auth tokens as well. So even that's bad, but we do have to store these things. But the auth token's going to expire at some point. So we would want to store that plain text password, which don't do that. Goodness gracious, don't do that. So very bad. We're going to be tempted to store plain text passwords or ask the user for their password every time their auth token expires. All bad news. We don't want to do that. Okay, the next one seems reasonable on the surface. So this one I have to explain a bit. I already stated that this is bad, but I got to explain why this one is so bad. This one is going to take a little bit longer to explain. Have the user go to GitHub, get an API key, and then hand that key over to me. Just give me your API key. It doesn't have the same problem as storing passwords. We just said that it's not terrible for an API key to be compromised, especially if it has restricted access. Nobody's going to change your password with an API key. You'll still have access to your account. They might make create some issues on some repos that you'd rather them not make. They can do some, post nasty comments or something, but not the worst thing. Still bad. Don't get me wrong. Don't ever put yourself in that position. But not as bad as the password, but still not great. So this is vulnerable to a lot of attacks. I'm going to leave it at that for now. But also, one thing that I'm not really going to mention later is the rate limiting. A lot of APIs will rate limit. It's expensive to run servers, especially when you have lots of users, handling lots of HTTP requests. So APIs are going to limit you at some point. Some of these limits are ridiculously high for like testing purposes, like hundreds of requests per minute or per second even sometimes. It's really high. Actually got rate limited on my Spotify API though when one of the days that it didn't work, the most recent day that it didn't work, it was because I was rate limited. Too many requests I got is the 400 level response. Because I am making requests in a loop in certain conditions and something went horribly wrong where that loop just ran away and went infinite. I checked my usage stats on the API and I was hitting, I believe it was in the hundreds of thousands of requests. And they finally started rate limiting me after that. So it takes a while to get to the rate limits if you're a single user and not abusing things. They want these limits because people will abuse things. If you use the Spotify API and try to just crawl all of their data and then build your own site using their data, they don't want you doing that. Is why they got to rate limit these things and the expense that I mentioned. So if they just give me their API key, now I am using that key, my user's key, and then accessing the repo, accessing the API. If I am not careful, I'm going to start using up their rate limits, and then I might get them denied access. Not the biggest deal. They're a little inconvenienced if they're also using the same API key, or actually it's going to go against their account, so that's a little bad. But of course, it's a much bigger problem if it's a paid API and the user put in their credit card for like the Twitter API, which is expensive now, and I start racking up a bill on my user's behalf. They're not going to be so happy with that. So that's a much bigger problem once money's involved. OAuth 2.0 solves all this. So all the problems are just going to go away once we're using OAuth 2.0, the coolest, most magical thing. I just got spam. Oh, should I respond to it? They want me to get an apartment in Buffalo from a number not in my phone. So OAuth 2.0, Open Authorization 2.0, the current, and by that I mean the most widely used solution for this problem out there right now, meaning you're going to run into it. This is what all the big players are using right now, GitHub, Spotify, Google, Microsoft, this is what they're using these days, almost to a detriment, if you ask me, in my opinion, that it's used in most cases exclusively, which means that first case, and we'll see the extra complexity that this adds, that even if you just want to get an API key for your own personal use, the first example that we showed, if you just want to say, hey, GitHub, give me an API key, it doesn't really work like that anymore. Because they use OAuth 2.0, you have to go through the whole OAuth 2.0 process as though you're a third-party app using their API. So it's a few extra steps. So even if you just want to use this for your own personal use, kind of got to deal with OAuth 2.0 these days. It's just part of the world these days. All right, so this is out there, it's being used, and it's designed for this exact problem. I want to write an app where I can access a third-party app on my user's behalf in a secure way. Now, the user still has to trust the app. So when I say secure, there is a level of trust here still. If you allow an app to access a third-party API on your behalf, you are explicitly giving them permission to act on your behalf. You have to trust the devs of that app that they're not going to do something malicious and that they're not going to do something incompetent, that they're going to be careful with the way they handle your data because they have the capability to wreck things. But outside of that, any attackers that are monitoring this situation, any eavesdroppers, any man-in-the-middle attacks, any known attack, for the most part, OAuth 2.0 is designed to handle those attacks. But you do have to trust the app. All right, so we have a few entities, and if you read up on OAuth, it's more confusing than it has to be, in my opinion. So I'm going to try to explain this in the way that makes sense to me, while also relaying it to the vocab used by the spec. And I linked the RFC in the course website if you want to check out the official documentation. And there's a few third-party sites that explain it as well. But whenever the documentation says client, that means your app. This one tripped me up for so long. But client means your app, not the client. Like I would always think of this person as the client, the end user of my app. That's what we think of as client. We have client and server all the time. But your server is the client. The user is called the resource owner. And then the third-party API, I'm going to lump them into one server, but it's broken down into the authentication server and the resource server, whether you're authenticating or actually accessing the data of the API for those two things. So we have these four separate entities. And the way we want this to work, this is not how OAuth 2.0 works. Just throwing that out there right now. But this is the way we would want it to work. This is the nice simplified view of what we want to happen. Is our app is going to talk to the client, or rather the client's going to be happily using our app. And they're going to want to do something that needs third-party API access. Our app's going to say, okay, we can do this, but there's a few steps we got to do first. So our app's going to say, look, you're going to have to get an API key for me to use, and from the third-party API that we want to use, and then send me that API key. Client says, the user, I'm going to try to be consistent. The user, the end user here, is going to go to the third-party API, grab an API key, send this API key to us, and then we use that API key to access the third-party server on their behalf. This is what we would want to happen. This is not how it works. But this would be a lot simpler. If any of you who have set up OAuth before on anything they've done, you know it's a lot more complicated than this. All right, so there's a few problems here. And they're all security issues. They're bad. We got 3 security issues here. That the API, when I start accessing this API, when your app starts accessing the API, you're sending the API key that the user requested and using that API key. This is the problem that we saw on the other slide, the rate limiting, if this API charges, it has those issues. But it also has the problem of there's no way of confirming that this is a legitimate access, or has this key been compromised? If this user wasn't careful with this key, that key might be in anyone's hands, and there's nothing from the third-party API side to say if this API access should be allowed or not. So it says, you got the API key, that's allowed, baby. There's nothing else it can do. It's got the key's valid, that's a valid request. So no matter what happened over here after this key left the server, that key could be compromised and sent to everybody on the planet, making API requests, and that server just has to accept all those requests. Because maybe that's what the user wanted. Maybe the user wanted to share it with everyone. The user handles their own API key. Security issue number 2. The user handles their own API key, which means this key can be compromised by the user. When should we trust our users? Never. We shouldn't trust our users to not be attacking us, but we also shouldn't even trust our users when it comes to their own security. That's how much we don't want to trust our users. We have to trust our users to create strong passwords, and even that is not great, that our users won't do that very well. But we don't want to trust our users. They might have some spyware installed. They have this cool browser extension that puts everything in dark mode, but it's actually written by a hacker who's keylogging all their information and stealing everything that they have. And they don't even know about it. So that key can be compromised at this point, especially we can secure everything here. The third-party API can secure everything there. But right here, this is a big vulnerability point. We don't know what this user is doing. And they might compromise their own key without even knowing it. And security issue number 3, there's a lack of accountability. We're actually making API requests this is where I almost misspoke earlier. We're actually making API requests as our user. We're sending these requests, consuming these API endpoints with this API key that was issued to the user. From the third-party API's perspective, this user said, give me an API key, please. Okay, here's your API key. And then sees requests coming in. The third-party API doesn't know that this exchange happened. It just knows it's getting requests with the API key. So it doesn't know if this user just went to a different network and their IP address changed, and that maybe this is the user. The API doesn't know. And the API has no way of knowing. It just treats these requests as the user, not on behalf of the user. There's nothing here saying that I am an app that's making a request on behalf of my user. No, I'm just making requests as my user, which is a little scary. There's a lack of accountability here. If this app goes rogue, there's no detection here. The third-party app just sees a bunch of legitimate requests that look like they came from the user themselves. My app can do all kinds of damage with no accountability. Okay, so OAuth 2.0 is going to solve all of our problems, and it does it really with one fix. There's just one big core thing that OAuth 2.0 adds to the mix here, is issuing API keys, which in the spec are called access tokens, because why wouldn't there be another different name for these? Why they couldn't just be called API keys? That'd be too easy. So I had to come up with a different name. Access tokens. They're going to issue these access tokens to our app directly. Our app is going to ask the API, the auth server specifically, for these access tokens. The API issues the access token to our app, and then we use that access token whenever we want to act on behalf of that user. So this is the big change, and it solves all 3 of our security issues. If any other app is trying to use the key, the request should be denied. The API, the resource server part of the API, should see that request, verify that it's coming from our app, verify that the access token was issued to our app, and then only accept the request if everything lines up. So if this token is compromised and somebody else tries to use it, that shouldn't work. Shouldn't. There's a lot to it, but it shouldn't work. The user never handles their access token ever because it's issued directly to our app. And our app is now accountable for all the access because it's clearly coming from the app. If the user's like, hey, I didn't post that, the API can look through their logs and see that it came from my app, and I'm held accountable for that action. Probably going to lose all my access to that API, and my app's going to, if that's a core part of my feature of my app's done because I just got shut down. There's some accountability there, which is why we can reasonably trust the apps that we use that use OAuth 2.0, because they don't want to lose their access, because then they lose their business. So there's accountability is nice on that side. So this is what our picture actually looks like. We have quite a few, well, only 2 extra steps here, but quite a bit more explanation that has to go into this. We got some time. We might get through all these. If not, we can, this leads into the email content on Wednesday, so we can talk about OAuth a bit more Wednesday if needed. But I think we can get through all this. All right, so let's take a bit closer look at this picture and see what the hell is going on. I like this picture a lot better, by the way. It's more complex. It's more of a pain to set up using OAuth 2.0, but it solves those security problems. All right, so bless you. So step 1, we're going to go through these one at a time. Step 1, the authorization request. So our users using our app, they're happy, and then they want to take an action that requires third-party API access. And our app is going to say, okay, I'm happy to do this for you, but we got to do all the security stuff because I can't just go over there and do this on your behalf. We got to do a whole dance here. So I'm going to send an authorization request to the user. And this authorization request is going to contain a lot of important information. Mainly, I'm going to identify the app, and it's going to contain the roles that I want to be able to access. So anything that I want to access from this API might be everything. It might be only one thing. Maybe I just want to start and stop music, but maybe I want to create playlists and add songs to playlists, remove songs from playlists. Depends on what access I want. And the APIs are going to have this broken down into different roles that you can choose from, and then you choose which roles you want to ask the user for. So the authorization request is going to say, I would like access to these roles. The client is going to take that authorization request and run over to the third-party API, specifically the auth server part of it, and say, I got this authorization request. Here you go. And the API is going to authenticate the user first. You need to be logged in for this, so either username and password or auth token if you're already logged in, if you already have an authenticated session with the server. Then the server is going to say, okay, I'm looking at this authorization request. This is for an app called Music Timer, and they would like access to these roles. This is everything that they'll be able to do if you allow this. Are you cool with this? And you've seen these just as a user of the internet. I'm sure you've seen these plenty of times. You have to click whether or not you're okay with this, because these are the roles that they're going to be allowed to use. And if the app is asking for more roles than you're comfortable with, you just say, no thanks. But if you're cool with it, you click agree and say, all right, let's do this. If we agree, we move on to step 3. Step 3, the user's authenticated by the auth server. They clicked, yes, this is cool. I want to do this. I want to give API access to this app over here. Then the server is going to give us give the user an authorization grant. This is permission, explicit permission to use the API. And this is going to be in a redirect URI. I got the logistics up here a little bit. I better talk about it. The authorization grant is going to be in a redirect URI. So when you register your app, you'll say, here's the redirect URI, which is where the third-party API, the auth server specifically, is going to send your user after they click yes. So once you click, yep, this is cool, they're going to respond with a 302 containing the authorization grant as a query string to that URI. That's something that your app specified. You specified when you registered your app with the API. Man, getting through this, there's so many little details. The app registered that redirect URI, and that's where the API is going to send your user with this authorization grant. So that authorization grant goes through that URI. Our app sees a request on that URI that we specified, on that path that we specified, and we read that query string, which contains the authorization grant, most importantly, the authorization grant. Most importantly, a token, which is what we're going to use in the next step. That's part of the authorization grant. But the authorization grant is the server saying, okay, this client, they said, yep, here we go. We're doing this. So we have permission to access the API, but that doesn't mean we can access it quite yet. We need to take this authorization grant and cache it in with the authentication server. We're going to send this authorization grant to the server. And this is the key part that gets rid of a lot of our security issues. We send this grant to the server, and the server sends us the access token. This is important. It's kind of an annoying step when you're setting these things up, but this is important because this means the user never handles their access token. They only handled the authorization grant, which didn't grant any access. It didn't give any access, but that's just like a slip that says, like a permission slip that says this app can access that API on my behalf. So when we send the authorization grant over to the server is going to authenticate my app, make sure that it is actually me, that I'm allowed to cash in this grant, and then send me the access token to be able to act on behalf of the user. As long as everything checks out, I have to be who I claim to be, and the authorization grant has to be valid. Then I get the access token, and then finally we consume the API. So quite a few extra steps involved here. Yeah. You would store that on your server. Yeah, or a database. I guess the database would talk to the file system for you. In a secure way, but if there's API access not coming from our app using that access token, it shouldn't be respected. So if that token is compromised, it's not like an auth token being compromised because those requests wouldn't come from our app. And we'll have a client secret. It's actually the next slide. We'll have a client secret which will identify our app, and that's how the client's going to verify that it is coming from our app. And we got to keep that secret, or else then attackers can start using our access, I always forget what they're called, access tokens. So when we register our app, there's 3 key pieces of information. A client ID that identifies our app. This is generated by the API. The secret, also generated by the API, and we need to keep that secret if possible, not always possible. And the redirect URI that we provide to the API, and that's where the API is going to send users after it generates that grant